think of an animal. More than likely, you probably thought of something like a puppy, a kitten, a rabbit, that sort of stuff. And that's typically what we think of. As we learn, a lot of our animals are actually invertebrates. In chapter 26, we do finally get into those vertebrate animals that we naturally know more things about because we see them in things like children's book. We have stuffed animals with them. We have learned about them. We watched videos on them. And so in chapter 26, we talk about the vertebrates. And so when we look at last chapter, we focused on the invertebrates, and the word invertebrate means lacking a backbone. And so as we dive into this chapter, one thing that we want to kind of clarify is that a chordate, by definition, doesn't necessarily mean it has a backbone. Instead, what it means is that it actually has what's called a ventral nerve cord. So when we look at this division of these chordates, tunicates and lancelets, they actually don't necessarily have true backbones. Instead, they do have a dorsal nerve cord. When we get into this, where you actually have bone around that spinal cord, then we actually get into the true vertebrates. So there's kind of a little bit of course, science always has to have something going on, and so we call these chordates officially more so than vertebrates. So what makes a chordate a chordate? They're what we call deuterostomes. They also have a notochord, as mentioned. It's dorsal, and so you have a lot of organization with these. All of us actually are conceived or start off with having gill slits in our pharynx. Many of us lose our gills, so most of us don't have gills that we breathe through. Instead, we have lungs, but we actually all start off with having these little slits for breathing. And then we also have embryos that have a tail that goes past the anus. So in other words, all of us have tails. Ours, as humans, we lost ours evolutionarily. However, we still do have a tailbone called a coccyx, but it's not as long anymore because we don't use it for balance like how we did when we had 4 feet and we used it for balance and we came from the primate family. So let's talk about these tunicates. They're kind of unique. I think I want to show the picture right away, but this is a tunicate. You kind of see how it's got this little line going down its back. That's what we mean by the dorsal nerve cord. Now you look at them, they're not real complicated things. They have an opening here where they help for digestion, but the reason why they're a little bit more advanced is because they have that dorsal nerve cord. And so these tunicates, here's kind of the life form of it. You do have the pharynx, so that's kind of where they're breathing in, and then that nerve cord, that's why they're considered to be a chordate in this regard. But again, it's not true bone. You don't have bone until you get to the first division of fish, but you do have that dorsal nerve cord, and that's why they're called chordates. Lancelets are kind of they're ugly creatures, but they're still a type of chordate. They are somewhat fish-shaped, and they're filter feeders. They do have some of the advancement of fish, but they're not quite in that division. Here is a body plan of what a lancelet looks like. Let me just show you this first. So that's what they look like. They're almost wormy looking, but as you see this dorsal nerve cord that goes around it, and so that's why they're considered to be a chordate more so than a worm. You still have some of the complexities of like a mouth and an anus. You have different levels of skin. Here you see the word epidermis. You have some muscles that allow them to move a little bit. And so that's kind of what makes them into this division rather than worms. There's also what are called craniates. These are kind of the in-between. They're fish-like in some ways, but they're not true fish. So they kind of are a combination of early fish and then what are called lampreys. And here you kind of see an artist's rendition of what they might have looked like back in the day. So these are, for the most part, extinct now. They are extinct. And the significance, though, is that they might have given rise to what we actually have as fish. So when we look at our earliest fish, or creatures like fish, we have the jawless fish called lampreys. These also not real good looking. That's what they typically are, is they're bloodsuckers. That's the mouth that you're seeing of a lamprey, somewhat worm-like, but you're also seeing that dorsal nerve cord that's at the top, and that's why they're considered to be chordates. And so the evolution of this is that instead of it being that notochord, you actually get a vertebrae, and also a development of a brain. And it's always been life's goals to try to protect the most vital organs. And so you know, just like us, we have a cranium that's around our brain, and we have now a vertebrae that goes around our spinal cord. And if we have injuries to those things, it's usually bad news bears. But as we got the evolution of fish, we started to see fins that allowed them to swim better. Those fins gave rise to limbs with the amphibians, and gills eventually gave rise to lungs. And so, big trends that we talked about in evolution, living mainly in water to moving on to land, starting off simple, going to complex, both of those are shown in the vertebrates and in the animals, just like what we saw in plants and in fungi and those types of things. And so that's our little introduction to the vertebrates. So now that we have introduced kind of the chordate, remember that doesn't necessarily mean that they have a backbone, it means that they have a nerve cord. Now we're going to get into the actual vertebrates where you have a true backbone, and that's where the definition comes from.